I'm going to talk a little bit about sound. Sound is a common longitudinal wave, and longitudinal waves are characterized when the energy is moving parallel through the medium. When the medium is compressed, we call it a compression. And when it is not, it's called a rarefaction. The length between compressions would be the wavelength. Something that happens when we hear sounds or hear music are beats, because there are often multiple frequencies being played at the same time. When the frequencies are pretty close together, for example 250 hertz and 260 hertz, we would hear something like 255 right in the middle at a fluctuating volume. In addition to beats, frequency can be altered by relative motion, which would be the Doppler effect, in which we use to track how fast cars are going, or in many other instances. It's important to note that the frequency changes by the same ratio as the relative speed compared to sound. So if the mass is going this way that's making the sound, the wavelength goes down and the frequency goes up on this side, and on this side the wavelength will go up and the frequency will go down. Let's get a real eraser here. The last thing I want to talk about is resonance, and we use resonance to amplify sound. And in order to amplify sound, the wavelength must fit properly within the structure. So, for example, when you have an instrument and you're playing strings, it looks like this. And the wave can either be going up or down. And here's where you have an antinode and a node here. Here, L equals wavelength over 2.